There are some basic matrix operations, or better to say math operations, which are operating on matrices. So these are addition, subtraction, multiplication, transpose, power and element wise operations, as well as division. One important thing to keep in mind is that for any kind of mathematical operation that is being done on matrices, the requirement of dimensional compatibility is a must. If for that particular operation the matrices are not compatible, the operation will not execute and it will not give us result. So let us first see the addition and the subtraction operation on matrices. And the compulsory requirement for addition and subtraction option in a matrix is that the size of both the matrix needs to be same, because it is an element wise operation. That means in addition, each element of one matrix gets added to the corresponding element of the other matrix, and similarly in case of subtraction, the corresponding element of the second matrix is subtracted from the first one. So in this case, we see that there are two matrices A and B. So if we run this particular section, we see that we get the matrix A as 1 0 0 1 and matrix B as 2 2 and then semicolon. That means the other row starts, then again 2 2. Now sum is addition of elements from both the matrices. 2 plus 1 is 3, 0 plus 2 is 2, 0 plus 2 is 2, and 1 plus 2 is 3. Similarly, difference is this: 1 minus 2, this will give you minus 1, and 0 minus 2 will give you minus 2. Now we come to the third operation, that is the multiplication. So for the case of multiplication, the necessary condition is that the number of columns of the first matrix should be equal to the number of rows of the second matrix. For example, for the matrices that we have already declared above, A and B, if we check the size of A and B, so it is a 2 cross 2 matrix. Similarly, if we check the size of B matrix, it is also a 2 cross 2 matrix. So 2 cross 2 means first row times column, row times column. That means matrix A is a matrix which has 2 rows and 2 columns. Similarly, matrix B is a matrix which has 2 rows and 2 columns. So for product, the condition is that the number of columns of A should be equal to the number of rows of B. So number of columns of A is 2 and number of rows of B is 2. So the condition is satisfied. Therefore, when the multiplication is performed, it will give us the result. So this is what the result is. Now one important thing is that the element wise product of matrix A and matrix B. So the important difference is that when we are writing A multiplied by B, we have A asterisk sign and then B. But when we are doing element wise multiplication, then we have a dot or a period symbol, then the asterisk sign and then B. So the difference between these two are like this. In the first case, when we are getting the product of AB, it is multiplying two matrices using the rules of multiplication for two matrices. But in the case of element wise product of AB, what it simply is doing is that it is multiplying the corresponding elements of each the matrix. So the result that we are getting is 2 0 2 0, and the reason for this is that in the matrix, when we do element wise multiplication, 1 will get multiplied by 2, 0 will get multiplied by 2, so it will make it 0. Then again 0 multiplied by 2 will make it 0, and 1 multiplied by 2 will make it 2. So that is what we are getting in element wise product, that is 2 0 0 2. So now we come to the division. In case of matrix division, the important condition that is needed is the size of both the matrices should be same. That is, the size of matrix A should be equal to the size of matrix B. And it is not necessary that they need to be square matrix, but the requirement is only that the size should be equal. Apart from that, we have two types of division in the case of matrices. That is the left division, where we will use left slash, and then there is a right division where we will use the right slash. For example, the matrix A left divided by matrix B is A left slash B. So if we execute this particular statement, we get this value. So obviously after division we are going to get quotient. In the same way, when we divide 4 by 2 we get 2, which is the quotient of the division operation. In the same way, when we are dividing a by b, we are getting the quotient part here. Now we see what we get in the right division. So if we perform the right division, we are getting something different. The reason being that when we are doing the division part, it can actually be thought of as it is going to be inverse of a multiplied by b, and this is going to be inverse of b multiplied by a, because b is in the denominator. So inverse of b multiplied by a. Fine. So when we are doing the right division here, then the result that we are getting is given with a warning, and the warning is saying that matrix is close to singular or is badly scaled, and we are getting something like this. So a divided by b is giving us this result. We can write this as a multiplied by inverse of b. It must be giving not a number. Okay, fine. So actually the reason being that if we find the determinant of b, it is 0. That means it is a singular matrix. So when it is a singular matrix and you try to find the inverse of that singular matrix, you will not get a inverse. It is non-invertible. But the division command is having some error in the values, therefore it is giving us the result even for the case when we are doing the right division, but it is giving us an error that the matrix is close to singular or badly scaled. So that is not of much use to us. We simply see that the left division can be done as this and right division can be done as this. This is done when we are trying to solve a inverse multiplied by b, and this is done when we are solving a multiplied by b inverse. Okay. Now the next operation is the transpose of a matrix or a vector. So we are simply taking the transpose of a vector for our example. So if we evaluate this section, it is a vector, it is a column vector. Now when we do a transpose of it, the column gets converted to a row vector. Now this is how it happens. So we see that we have a column vector, and when we find its transpose, we have a row vector. In order to find the transpose, we use this apostrophe after the name of the vector. So in this case, it is the name of the vector is double A, and its transpose is going to be double A dash or apostrophe. Now why we are using the transpose, or where do we need the transpose? So it is needed in finding the inner product, or using the transpose of a vector, we can find the inner product. So in this case, we have two vectors, double A and double B. To find the inner product of these two vectors, the equation is double A transpose multiplied by double B. That is vector A transpose multiplied by vector B. If we evaluate this particular inner product, we know that the output of an inner product is going to be a scalar, and we are getting the same thing. So what is happening is 1 cross 3 matrix is getting multiplied by this is a 1 cross 3 matrix getting multiplied by a 3 cross 1 matrix. So by rule of multiplication, it will give us 1 cross 1 matrix, that is a scalar value, which is 10. Now the same can also be used to find outer product. In the case of outer product, for these two matrices double A double B, where the dimensions are 3 cross 1, for outer product case we will get a matrix which is of the size 3 cross 3. And important point to keep in mind is that the rank of this outer product matrix is always going to be 1. So if we check the rank of this outer product matrix, it is 1. This element wise operation we have already seen, so we can see it once again if we simply, I should better remove the semicolon so that we can see the results in the command window. If I get two matrices which are of size 3 cross 2 and 2 cross 3. So in order to find the size of the matrix, the simple way is to use command whose. So the matrix array is of size 3 cross 2 and RB is of size 2 cross 3. So for product, for the multiplication of the matrices, the number of columns in the first matrix should be equal to number of rows in the second matrix. So this is true for these scales also. Therefore, if we find the normal product of the matrix RA and matrix RB, we get a 3 cross 3 matrix. On the other hand, we can also do element wise multiplication of RA and RB, and the result is going to be different. Okay, so important thing is that whenever you are doing element wise operation, that means element by element operation, which is also called as array operation. In that case, the compulsory requirement is that the size of the matrix A should be equal to the size of matrix B. So as earlier we have seen that the RA and RB are not of the same size, they are of different dimension. They have same number of elements, but they are of different dimension. And that is why when we are trying to do element wise multiplication here, RA dot asterisk RB, it is showing us an error. So what we can do, so what we can do is that we have to change the size, and for that, if we take the transpose of RB, then it will become 3 cross 2, so the size will become same. So now again writing the same command, but in this case I will use RB transpose and it should work. So we can see that the multiplication is working. The opposite will also be true, that is, if we take the transpose of RA and then multiply it with RB, this will also work. But you see the output, the dimension of the matrix changes, because in this case when we were taking the transpose of RB dash, the final matrix size is 3 cross 2 for RB dash, and for RA it was already 3 cross 2. And when we do the element wise multiplication, we get an output matrix which is of the dimension 3 cross 2. But in the second case, the size of RB was 2 cross 3. You can see here the size of RB was 2 cross 3, and when we take a transpose of RA dash, we get a matrix which is of the size 2 cross 3, and the element wise multiplication will give you this. So that's it for today. Thank you.